Alright, so today we're going to do volume of prisms and cones. So, you're not talking anymore. So your topic is volume. Well, I suppose I should put the word of in there. Of prisms and cones. These are notes for 11-8. The longest unit in the world. Okay. So those of you watching the video won't be able to see the demonstration, but the rest of you, so this is a cube, right? Would you agree that this pyramid has the same exact base as this cube? All in agreement? If I turn the pyramid upside down, would you agree that the pyramid and the cube have the same height? Right? What do you think the volume of this is compared to the volume of this is? It looks like it's half, doesn't it? I know, because you're looking at your paper. It is 1/3. So if I were to take this pyramid upside down like a cup, and I were to fill it, I left my demonstration at home. Sorry, you don't get today's demonstration. You would fill this with water and pour it into this cube. It actually will take 3 of these to fill it. I've done it for years. Trust me, it takes 3 to fill it. So the volume of anything pointy, volume is still area of the base times the height. As soon as you have something pointy, like a cone or a pyramid, then you're going to take 1/3 of that. So it's no different than what we did on 11-7. You're still doing area of the base times the height. You're really not learning a new formula. You're just taking 1/3 because it's pointing. We've shaved off part of it, and we have just a little bit less. So let's go over some of these. We're going to go over number 1. It's fairly simple. So as we look at number 1, what shape is this base? A square or a rectangle? Is it a square? Because I got 10 by 11. So that's a rectangle. Okay? And then our height is always perpendicular to the base. So you'll see the height coming right through there like the tent pole, the big massive tent pole of a tent, right? So it's going to, and you'll see this little perpendicular marker there. So the 16 represents my height. So I already have my H, I just have to find big B. So step 1 is big B. Big B for a rectangle is length times width. So I'm going to let the 10 equal my width and the 11 equal my length. So we're ready to plug and chug. So my length is 11 inches. My width is 10 inches. And then 10 times 11, big B is 110 inches squared. So then we just have to use our formula, step 2. Volume is equal to 1/3 big B times H. So I have 1/3. My big B is 110 inches squared. And then my height, we already noted, was 16 inches. So in your calculator, you're going to multiply these together first. And then what do you do with the 1/3? Whenever we're multiplying by a fraction that's 1/2, 1/3, 1/4, 1/5, 1/6, what does that really mean we're doing? We're dividing by that denominator. So we're going to multiply these together, hit equals or enter, and then divide by 3. So you're going to get a final volume. So let's see, 110 times 16 is equal to 1760 divided by 3. We get a lovely repeating decimal. So I have 586.666666666. What does that round to 2 decimal places to? 67. Inches squared times inches is inches cubed. So there's our volume. So is that any harder or different than what we did on 11-7? other than the extra step of dividing by 3. So it's no different. So let's look at some harder problems than we looked at when we did 11.7. So let's look at number 3. Remember, I need area of the base times the height, and I'll take a third of that. So do I have the information to find the area of this base?
Yeah.
What's the area of that base? I mean, what shape is it? It's a square. So big B is equal to side squared, or you can do length times width, either way. My side of this square is 14 feet. So big B is equal to 196 feet squared. However, I need my height. Is this the height of the pyramid? Is that the tent pole holding up the tent? The pyramid's a tent. No, what is this called? What is that called? The slant height. What do we use slant height for? Surface area. So we don't need that slant height here. We want the height. And so what I want is this right here. I want that height. And that height is going to be a right angle to my base. And I'm going to create a line right here from the height to the bottom of that slant height. And I'm going to call this, well, we could call it X right here. But what is this distance compared to this distance? It's half. So if I know that this whole distance is 14, what do I know this is? 7. So we're going to put 7 here. I'm not going to put 7 feet because it's hard for me to put 7 feet in there. So that's 7. I don't know my height, so I'm going to label that as H. But this slant height here is what part of this right triangle? The hypotenuse. So if I know 2 sides, how do I find the third side? Pythagoras theorem. So let's go ahead and use it. So I have, my legs are H and 7, so I've got H squared plus 7 feet squared equals 25 feet squared. So H squared plus 49 is equal to 625. So take 625 and subtract the 49. We get H squared is equal to 576. What do I do now? Take the square root, and I get a pretty answer of height is equal to 24 feet. So that's one of the pieces that I'm looking for this problem. So now I have my area of the base, I have my height. We can go ahead and apply our formula. So step 2, volume is equal to 1/3 big B times H. So our big B is 196 feet squared. And our height we just found was 24 feet. So you're going to multiply these together first. So 24 times 196. And I get 4704. Then we're going to divide that by 3. And we get a volume that's equal to 1,000. That's a lovely comma. 1,568 feet cubed. So that's something that you should have done in 11.7 is use that triangle within the figure to help you find a missing piece that you need. The last one of these, maybe we'll do a couple of them. Let's look at number 4. So number 4 is a triangular base, right? What kind of triangle is this? Or do I care? Do I even know? Have they given me these sides? Do I need that for big B? What do I need for big B? my base and my height. Isn't that the height of the triangle? Isn't that the base? So this right here, the 7.5 is our height of the triangle, whereas this is the base of the triangle. What does the 10 here represent? The height of what? The overall, the overall pyramid. So that's the height of my 1/3 big B times H. So we've got that, we just have to find big B. So big B, what is the area formula for a base that's a triangle? 1/2 base of the triangle times the height of the triangle, right? So 1/2, we're going to plug in our values. We've got 12 millimeters. And then our height of the triangle is 7.5 millimeters. Throw all that into your calculator. So 12 times 7.5 is 90, and then we're going to take half of that. So we get a big B that is 45 millimeters squared. So that's my big B. Now all I have to do is apply your formula. So I'm going to let you apply the formula. Nathan, you should be taking notes, not picking at your fingers. Thank you, George. So let's go. You do this on your own. So what'd you get for volume? What'd you get for volume? Katie, what'd you get? What'd you get? 130? Nope. Is that what you got? 130? It should be 150, so I don't know what you girls are doing. Did you do it by hand? Okay, you might want to get a calculator. You've had 2 weeks to get a calculator. So it should be 150 millimeters cubed. So I only brought that one out just so that you could see that here they're giving you that height, but look at this one. Do you have what kind of a triangle is this one? A right triangle. Do you have the base here? Do you have the height? No. What's the 19 referring to? The height of the pyramid. How are you going to find this height when you know this side and this side? Pythagoras theorem. So can we skip that one? Okay. Let's go to this one. What kind of triangle is this one? Yeah, what is this pointing to? It's pointing to that side. So this is actually an equilateral triangle. So you could use 1/2 big P times A, because an equilateral triangle is a regular polygon, but that's a whole lot more work than just doing the following. Let's take this base right here, and I'm just going to redraw it over here. So let's redraw it over here. It's kind of upside down. And I know that this is 10, 10, and that this is 10, right? What happens if I draw a height from this vertex to that base? What happens to this base? What happens here? When I draw in the altitude, what happens to the base? It splits it in half. So I've got a 5 and a 5 here. So you have a couple of options. I need to find the height of that triangle, that triangular base. I could use Pythagoras theorem, right? Or what do you know about the angles in an equilateral triangle? Nope, they're not 45. They are 60, 60, 60. So does not make this one here 30? So let's use our special right triangle knowledge because it's a whole lot quicker. The math is a whole lot easier. So we're going to use our 30, 60, 90 knowledge. And so what goes under 30? 1. What's under 60? Radical 3 and 90 is 2. Equals. Then what are you going to put underneath the 30? What's across from 30? 5. What is across from 60? H. What is across from our 90? 10. So I care about H, so I'm probably going to use, I can use this proportion or this proportion. Which one do you want to use? This one's already reduced, isn't it? Right here. Doesn't that reduce to 1/5 also? Why not use this proportion here? So we're going to use this proportion and cross multiply. And if I just cross multiply, don't I get H is equal to 5 radical 3? And that is the height of my triangle. My base of my triangle is this one. So now I'm ready to find big B. So step 1, big B, is 1/3 base of the triangle times the height of the triangle. So I get 1/3 times, oh yeah, thanks. Good thing you're paying attention, right? I was on a roll. Okay, so then our base of our triangle is 10 centimeters. Our height of the triangle is 5 radical 3 centimeters. And so we have 10 times 5 is 50. Divided by 2 is 25. So I have a big B that is 25 radical 3 centimeters squared. Notice that I did not find the decimal equivalency yet. Why? Yeah, don't round in the middle of calculation. Leave everything exact. Okay? Same thing would have happened if you had used Pythagoras' theorem. You're not going to find the decimal equivalency of that radical, and that's what a lot of you are going to try to do. You're just going to run it through Pythagoras' theorem. You're going to end up with a decimal, and you could have rounding errors. So just be careful. So now, what is the height? Because I'm going to use 1/3 times big B times H. What is the height of this pyramid? So 16 is my overall height. So now I'm ready to plug in the numbers. So 1/3 times big B, which is 25 radical 3 centimeters squared, times our height, which is 16 centimeters. So on in your calculator, you're going to, if I were you, I'd do radical 3 first. So 3 radical or radical 3, depending upon your calculator and how it works, times 25 times 16 equals. So if you do all that, square root of 3 times 25 times 16, you get a decimal of 692.82, that's rounded. And then we're going to divide by 3. And so you end up with volume approximately equaling 230.94 centimeters cubed. Can I do what? It depends on your calculator. You either do 3 radical or you do radical 3. It depends on your calculator. Some of them you do it backwards, some of it you do forwards. But your radical 3 should turn out to be 1.7. So which way did it work on yours? Is that because you have the solar? Yeah. Let me see your calculator. Come on. It's one of the two. By now you should know how to use your calculator. Don't you use it at home?
Yeah.
Okay, well, then yours is radical 3. So where's your radical button? Here. So second radical 3 equals. Get to know your calculator. All right, any issues, questions? questions, concerns? It depends on the triangle. This one you could have used Pythagoras theorem, but the problem that you're going to run into on this one, if you use Pythagoras theorem to find this, you're going to come up with a decimal here. Because you're going to do 8 squared plus 5 squared equals 10 squared. And you're going to have 100 minus 25, which is 75, and you're going to go into your calculator and do the square root of 75 is. And you're going to have a decimal here, which can affect, when you throw a decimal in here, now it's a rounded answer, then this is going to affect your answer here, and if you don't have 0.94, you're going to get some points marked off because you're rounding the middle of your calculation. It affects your accuracy. So you can use Pythagoras theorem if you simplify the square root of 75 correctly. Square root of 75 will simplify to 5 rad 3. So if you're going to do that, just be careful and simplify your radicals. Or you could have kept it square root of 75 because it's not our final answer. Does that make sense? You just put the square root of 75 in there. I'm okay with that too. Yes? Say that again? Because she asked, how do I know that this was a 30, 60, 90 right here? Equilateral triangles always have 60, 60, 60. Right? And when you put that altitude from the vertex to a base, it bisects this angle right here always. If it bisects this side, it bisects that angle just like it does on an isosceles triangle. Okay? Girls, stop. What else do you guys have questions on before we do the back? Nothing? Okay. So then let's scroll to the back. So we're only going to do one cone because the cones are pretty straightforward. Now this is not another formula. Remember our volume is 1/3 because it's pointy, big B times H. Isn't this big B right here? Pi r squared, right? And the same thing happens with a cone and a cylinder. Here's my cylinder. Here's my cone. Would you agree that this cone and this cylinder have identical bases? Yeah. Right? Would you agree that this cone and this cylinder have the same heights? Okay, if I could hold it steady. Would you agree? Yeah. So this is also 1/3 of its prism, the cylinder. So again, we're not learning a new formula. We're still doing big B times H. Just big B on a cone or a cylinder is pi r squared. So let's look at number 9. So here's the deal with number 9. I don't have the height of my cone, do I? What does this height do to this diameter here? It cuts it in half. So I really need my radius anyway. So what's the radius if the diameter is 27? What is it? 13.5. So that means that I'm going to have to use what to find h? Okay. So I'm definitely using Pythagoras theorem, so I'm going to do that off to the side here. And because I have decimals, I am going to have a decimal answer. But when I put it into my equation, I'm going to probably go out to 4 decimal places rather than 2. So I have h squared plus I have 13.5 squared equals 22.5 squared. So we get h squared plus 13.5 squared is 182.25 equals 22.5 squared is 506.25. What do you do now? So subtract the 182.25 and we get h squared is equal to 324. And now take the square root and we actually get a pretty number. Our height is equal to 18 kilometers. So that's our height of the cone, height of the overall cone. So now we're just going to apply, we're going to find big B, which is pi r squared. We're going to leave pi in our answer. Our radius is 13.5 kilometers squared. We already squared it in the Pythagoras theorem to the left. So I know that big B is equal to 182.25 pi kilometers squared. And so now we have everything we need to plug into our volume formula. Volume is 1/3 big B times H. So I have 1/3. My big B is 182.25. I'm going to leave out my units of measure. I'll never fit it in there. Times my height, which is 18. So in your calculator, you're going to want to do this first. The 182.25 times pi. Then times 18. Hit enter or equals, and then divide it by 3. So 182.25 times pi times 18 gives you 10,305.9947. Then you're going to divide by 3. And so our volume is going to be approximated at 3,435.33 kilometers cubed. Okay, so a lot of the same stuff we're doing. So let's look at our applications. We should have enough time to do our applications. On your paper, I'm not sure, by the way, if you can see this. Can you see these lines on your paper? Yeah? If you can't see them, make sure you put those lines in on your note paper, because on my answer sheet, I can hardly see them. So just make sure you darken those in. Yes? Say that again? Yeah, no, the clock's wrong. Okay, so let's focus on math instead. All right, so a cone has a volume of 1,309 cubic centimeters. So we're going to start with a volume formula for a cone. So volume of a pointy thing is 1/3 big B times H. So they gave me the volume, and they've given us the height of the cone is 8 centimeters. We have to find the radius. So that's fine. We're going to put in what we know, 1309. I'm going to leave my units of measure out, equals, and if you don't mind, I'm going to put the 1/3. Can I put, what's wrong? When you're talking, he can't hear and I can't talk over you. So if it's okay, I'm going to put the 1/3 as base times height all divided by 3. It'll be easier when we solve and use our algebra. So my big B for a cone is what? What's big B for a cone? Pi, no, big B, pi r squared. So I don't know r, so I'm just going to put pi r squared in here. I don't know r, but I do know my height. They gave me my height is 8 centimeters. I'm going to leave the centimeters out, but I know my height, all divided by 3. So this is my volume. This is big B times height, all divided by 3. That's your 1/3. So if I were to solve this problem, what would I do first? Multiply by 3, both sides by 3, right? So we're going to multiply both sides by 3 because I want to get rid of that fraction. So these are going to cancel. And we get 1309 times 3 gives us 39. 27. That's a 27 equals 8 times pi r squared. I put the 8 in front. Now I want to solve for r squared. I want to get r squared by itself. What do you do? Divide by 8 pi, but make sure that the 8 pi is in parentheses, please. Because if you try to divide on your calculator by 8 pi without parentheses, it's going to divide by 8 but multiply by pi. Nathan, seriously, are you not taking notes? Okay, because I've been writing a lot and you haven't written anything. Have you already done the problem? Okay, because you look like you're doing nothing. Every time I look up, you're just sitting there doing nothing. All right, so we're going to take 3927 and divide it by 8 pi. 8 times pi. So use your parentheses. You should get, and this is a rounded, you're going to leave the whole decimal in your calculator, you're going to round on paper. So this is 156.25, and I'm going to put an extended decimal here, 0.4. That's equal to r squared after you've divided both sides by the 8 pi. Now what do you do to solve for r? Take the square root of both sides. So you've got the whole decimal in your calculator, just hit square root. Or some of your calculators you have to do square root, then second answer, and hit enter. And what it'll do is you'll take your answer from before and put it underneath that square root symbol. So if you need to know how to do that, I can show you how to do that later. And you get, for your radius, approximately 12.50, and our units of measure is centimeters. So that's similar to one that we've done before. Number 11, Caitlin must build a sandcastle in the form of a square pyramid. They have kindly given you the square pyramid over here for a project. She bought 3 bags of sand, each containing 1,200 cubic inches of sand. The question is, will she have enough sand to build that castle? She doesn't want to arrive at school to build a castle and find out that she doesn't have enough sand. Okay? So what do I start with? Find the volume of this pyramid and then compare it to 3 bags of this. So let's start with volume equals 1/3, because it's pointy, big B times H. What is our big B here? What shape is it? A square. So isn't the area formula for a square side squared? So we're going to put our side in there, which is 25 inches. Squared, which is 625 inches squared. And then, do I have the height of my pyramid? What is it? That right there. So this is our overall height. So we're ready to plug into that volume formula. So we have 1/3 times our big B, 625 inches squared, times our height, which is 18 inches. So take your 625, multiply it by 18, and you get 11,250, but you have to remember to divide by 3. So the volume of that pyramid is going to need 3,750 cubic inches of sand. So let's find how many cubic inches of sand she has. So how many sandbags does she have?
3.
So you've got 3 times the amount of sand in that bag is 1,200 cubic inches. What's 3 times 12?
3,600.
So she's got 3,600 cubic inches of sand. Is that going to be enough? Nope. She's going to be short how much? Yeah, she's going to be short 150. So therefore, Caitlin will not have enough sand. So she's short 150 cubic inches. You can put that in there. I've just ran out of room. All right, last problem. So last problem, again, make sure you've emphasized that we've got these lines in here. And it says the cylinder to the left contains 2 congruent hollow cones. So those are hollow, meaning that this is the only place where we have volume. If the cylinder's height is 20 inches, so we know that 20 inches goes from here to here. So what is the height of the cone? What's the height of each cone if they're identical and the height of the cylinder is 20 inches?
10 inches.
Yeah, so this height right here must be 10 inches. So we're going to need that. We know that the diameter is 14 inches. So if the diameter is 14 inches, what's the radius? 7 inches. So how am I going to find the volume of this cylinder? Discuss in your table groups how you're going to find it. Yeah, 2 hollow cones. All right, so stop. Allie, what did your group discuss? How are you going to find the volume to that cylinder? Shh, listen up. Can you find the what? This? What am I going to do with that? Times. So what's the volume formula for a cylinder? Times the height. So it's big B times H, right? So don't forget to multiply it by H. So she's going to find the volume of the cylinder and then do what? And then do what? What are we going to do with these cones? George? So we need to find the volume of the cones, right? And there's 2 of them. So you just have to find the volume of 1 cone and double it, don't you?
Yeah.
And then subtract it from the volume of that cylinder. So that's what you're going to do right now in your table groups. You're not going to look up here at all unless you get stuck. So I'm going to quietly do it here, but you're doing it at your table groups. Don't work independently. Talk to each other. All right, go. You guys ready for the answer?
Can you give us like a minute?
Yep, I'll give you a minute. You guys ready for an answer?
Yeah.
What'd you get? What'd you get, Dustin?
Can you tell us first?
What'd you get? Do you have a calculator?
Yeah, but I don't know if I did it right, so I'd rather you tell
Well,
us.
did you look up there and see what I did?
I mean,
Anybody notice my mistake?
Yeah, I can't really.
I can't really read it. It looks like scribble.
Yeah, you used a 20 instead of a 10.
Yeah. So originally, I goofed and was using 20 here,
I
right?
did that too.
Right? So this height, remember, needs to be 10.
Yeah.
So I went and fixed that. So your volume of your cone should be 163, and it's really a third, it's 0.3333 pi. This, how did I get what?
Yeah.
This, I multiplied 49 times 10, which is 490, shh, and then took a third of that. Right? 490.
Oh, you didn't multiply by pi.
Right, and so your final, hang on, don't go anywhere, stop. Here's your answer, and I gotta give you your homework, don't go anywhere. There's your overall volume.